Lucas will talk about the active canopy sensors on sugarcane. It's at least 5 years or more history or things like that.
Thank you. Well, good morning. My name is Lucas. I recently got my PhD in the department, but I'm still around. And I'm here today to tell you a little bit about what our group have been doing on canopy sensor in sugarcane. First of all, I'd like to introduce you our supporters. This is our supporters, and it's important to mention that the sugarcane study was part of a bigger project. This project deals with a lot of sensors in agriculture, and it's also financed by the Brazilian government. Okay? And just to let you know, the sugarcane was the main point here, the principal topic from the presentation. But at the same time, we have been working with the sugarcane since our group conducted some studies on wheat and corn using canopy sensors. And actually, the wheat approach or the wheat algorithm is being used commercially by one of our former graduate students. Now he's a researcher and he's applying this technology commercially on wheat fields. But corn, we faced some difficulties and it's a little stopped now, but we plan to work more in the future. Now sugarcane. We choose to work with sugarcane because it's a really important crop to us, Brazil. Sugarcane is related to energy production and sugar production, and Brazil is the main producer of this commodity, working with 35% of the harvest area. And we need to address the nitrogen in this crop, because nitrogen is still a challenge for the growers, since the sugarcane frequently show a variable response to this application, and consequently a low nitrogen use efficiency. So you have to improve this, because the nitrogen use efficiency is about 20 to 40% only. So you have to improve this use. And this is a high-cost input fertilizer, and there are some environmental issues about this use. So we have to address and improve, optimize the nitrogen use efficiency. And here we have another problem, because under tropical conditions and Brazilian conditions, we don't have a soil analysis available to estimate the nitrogen availability in the soil. And as well, we don't have a reliable yield monitor to work on sugarcane. We actually have one, but we cannot trust yet in this equipment. So the producers don't have an option. They have to apply the nitrogen in a uniform rate, only one rate, ranging from this small different doses here. Okay, so the main goal of yes, for crop season. So the main goal of our project was to establish or develop a way to use the canopy sensor to guide the nitrogen application in variable rate. It actually begins in our group in 2006. Professor Lee said 2008, but actually it was in the end of 2006 with Flavia here in the picture with Green Seeker. She did some work, and then in 2009 I started my master's degree and started to work with the crop circle sensor. It's a different one, but the object, the goal is the same. And I worked for 5 crop seasons in the São Martinho's mill that probably you met there yesterday. And I conducted several experiments during 5 crop seasons, during 4 crop seasons in different crop situations and soil conditions. So firstly, I worked with the model ACS210, worked with the Amaral, but further I started to work with the ACS430 and also the ACS470. So it's a little bit different. It works with the red light and the red edge, so it's a little better, as you can find out. Okay. At the same time, there was a colleague of mine working with the ESALQ sensor, the head sensor here, and further he started to work with crop spec, and our group now has all these sensors to work and analyze not only sugarcane but on cotton and maybe in maize as soon as possible. So we have run some comparison studies with these sensors. Like here we have 4 sensors, different sensors. This is a sugarcane field, and you can see that they work pretty similar. We can see the map is pretty similar. Some difference here because mostly due to the footprint of the sensors, but they are efficient, they are the same to identify some areas on the field with different crop development or biomass, because in the sugarcane conditions, the canopy sensor is sensitive to biomass variation. We have some difficulties with the sensors used in sugarcane fields, as I will show you. Well, I spent four months at the University of Nebraska working with Dr. Jim Shepard here, probably most of you know him. I worked and analyzed all my data from the sugarcane with him, and he classified the sugarcane as a bastard crop, as a beast, because sugarcane is a little or very different from the crops he used to work, like corn and maize in the US. It's completely different. Because sugarcane has a semi-perennial behavior. So we plant once and then harvest it for 5, 6, 7 crop seasons. So the plant population becomes the main issue here. We have problems with plant population, crop density. So this crop density variation makes it difficult to use the canopy sensor to really measure or identify the nitrogen status of sugarcane, the chlorophyll amount. That is usually done for corn and maize, for corn and wheat. But sugarcane is a little bit different. We have to work thinking that the sensor is identifying biomass variation and not, at least so far, and not the nitrogen status. Here some examples, some pictures of this problem, the crop density problem. Here you can see the variation of the plant development here, like in this row. Here you can see some pest attacks, and this problem here will stay in the field for the successive crop seasons. So it's a great problem. Here you have another field with several skips within rows, some failures in the ratoons. So it's what I have to deal with. Okay? So this intrinsic variability due to the crop density, we can say that impairs most of the nitrogen application approaches based on canopy sensor readings. Because the main problem here will not be the nitrogen fertilization, the nutrient in the soil, will be the crop variation. The sensor will be identifying this problem here, this crop density, the plant population, the skips here. So it will be the most important factor. So we have to work in a different way. For example, here, Yara, when it came to Brazil, they came with this idea here, where the sensor value is lower, which means we have plants deficient in nitrogen, we should apply more, because in that situation, in European situation or American situation, the problem would be the nitrogen. However, we are quite confident that in most of the situations under sugarcane conditions, the problem will not be the nitrogen, but the biomass variation, the crop density, crop failures. So we have to apply more nitrogen where the sensor indicates that I have more plants. I have more plants, I have more vigorous plants. So our idea, we are quite sure that we should make the opposite. Apply more when the sensor value is high. It means that I have bigger plants, more vigorous plants. Okay? So this is our idea, our concept of what really happens in sugarcane fields. And here we give you some correlation about with biomass and yield. So we can manage our nitrogen application based on biomass variation. I have more plants, I have more vigorous plants, I have more biomass. So in this case, here for example, the predicted biomass by ER sensor and Rios, you can see a very good correlation with biomass. And this biomass is related to the crop yield at the final of the season. So you can measure this earlier in the field and then estimate the yield we're expecting. So here, for example, I have an MGRE, that is a vegetation index for crop circle sensor, and it's well correlated to yield. In this case, working with normalized data. So you can use this to apply nitrogen. So our approach, we are going to apply more nitrogen where we found high sensor value. Because when we find high sensor value, it means that we have happy plants, we have strong plants, we have more plants. So in this case, if I have more plants and more vigorous plants, we will have higher yields. And if you have higher yields, probably we will need more fertilizer. So if we need more fertilizer, let's apply more nitrogen here to supply this demand of the crop. So it's our idea. On the other hand, if you have low sensor value, it means that in that area, that part of the field, there are other growth limiting factors instead of nitrogen acting on the crop. Or you can even have a few plants caused by the racking damage. So in this case, do not make sense apply more fertilizer here, because we don't have plants, we have weak plants. We have water deficient, soil compaction, other nutrients problems. So you should save money, save fertilizer here. So apply low nitrogen right here. Okay? So unfortunately we don't conduct some validation studies yet because we have some problems with yield monitors, as I said to you. But we are going to start a validation study on commercial fields, maybe this end of the year, we don't know yet. But trying to use our algorithm we'll develop to guide the nitrogen application based on crop circle sensor Rios, or even ERS sensor, because we create both algorithms for ERS sensor and crop circle sensor. So that's it, just an overview, just to introduce you what we have been doing. There are some papers published, there are some events, some papers presented on events, so you can study a little more about that. But thank you for your attention, and I'm open to questions. Thank you.
Thank you very much for that. I can certainly appreciate everybody using these crop sensors in a sugarcane crop. Let's go back to the beginning. You had 4 sensors up and compared them. Actually, 4 sensors using different, even so slightly different maybe, different wavelengths of measurement. So really, you would not compare like with like. You put up 4 yield maps. Sorry, this isn't my way of sort of advisory really. You put up 4 yield maps and you say, well, they look similar. Yeah, but that's a very qualitative and a subjective assessment of whether in fact they were comparable. And as I say, will we really compare like with like?
Yeah, this is a little different sensors. Here is just what the field variability of the sensor, the readings, but we also have some samples there, measure the biomass, measure nitrogen status, measure counting for crop density, and we found out that the sensors are quite similar. I can say that the green seeker is a little worse to identify biomass, but the others are quite good, and this paper is recently accepted on Precision Ag, so it's a little, there are a lot of things to show you, but the times are so short.